Law number 1, multiplication of indices. Rule: when multiplying indices with the same base, we keep the base and add the powers, right? So you must always bear that in mind. Example number 1. X raised to the power of m times x raised to the power of n is going to equal to x raised to the power of m plus n. Reason being, the bases here are x, so they are the same, so we simply add the index, which is m and n. Alright? Example 2, a squared times a to the third power is going to equal to a to the 2 plus 3, because the bases are a here. So we keep the base and we simply add the index, which is 2 plus 3. That gives us 5. So our final answer is a to the 5th. Example 3. X squared y times xy to the 5th is going to equal to x to the second power plus the first power, right? Y to the first power plus the 5th power, which gives us a final answer of x to the third power and y to the 6th power. Note that y by itself means y to the first power, and x here means x to the first power. So here we have p to the third power times p to the 5th power. The bases are the same, which is p, so we're going to keep our base, which is p, and we're simply going to add the index, which is 3 plus 5, and that's going to give us a final answer of p raised to the 8th power. Alright, let's look at example number 4. We have p squared q to the third power times p to the first power times q to the second power. Now let's focus on the p first. We're going to keep our p and we're simply going to add the powers, so it's going to be 2 plus 1. We're going to do the same thing for q. We're going to keep our base, which is q, and we're going to add the index, which is going to be 3 plus 2, which is going to give us a final answer of p to the third power and q, or times q to the 5th power. Alright, let's look at example number 5. We have 3x squared y times 2xy to the third power. Now, in order to do this one, what we're going to do is to multiply the numbers or the coefficients of the terms. So we're going to put 3 times 2 in a bracket. Then now we're going to focus on the x term. So we have x squared here and we have x to the first power here. Remember, x by itself is raised to the power of 1. So I can put a 1 there. So I'm going to keep my x as the base, and I'm simply going to add the power, which is 2 plus 1. So it's going to be 2 plus 1. Then I'm going to keep my y. So I'm going to keep my y. And then remember, y by itself here means y to the first power. So I'm going to add the index, which is 1 plus 3. And I can quickly simplify this to be 3 times 2. That's going to give me 6. And x 2 plus 1, that's going to give me 3. So it's x to the third power. And then y to the 4th power. Because 1 plus 3, that's just 4. So that's your final answer there. Let's look at example number 6. We have 3xy squared times 2x to the third power, y to the 4th power, times 5x squared y. Alright? Again, we're going to multiply the coefficients together. So what we're going to do, we're going to open a bracket and we're going to multiply 3 times 2 times 5. To close our bracket. Then we're going to focus on the x's, right? So the x term. So x is the base here. Remember that x by itself here means x to the 1. So all we're going to do, keep our base of x, and we're simply going to add the index, which is going to be 1 plus 3 plus 2. Then now we're going to focus on the y. So we're going to keep our y. And we're going to add the index. It's going to be 2 plus 4 plus 1. So remember that y here is raised to the first power. Alright? Then we can simplify this to give us a final answer. So our final answer is going to be 3 times 2, that's going to give us 6, and 6 times 5, that's 30. So it's going to be 30x. We add up the powers here. So 1 plus 3, that's 4, plus 2, that's 6. So it's going to be x to the 6. Then put back our y, and then combine the index. It's going to be 2 plus 4, that's 6, plus 1, that's 7. So it's going to be y to the 7th power. So our final answer here is 30x to the 6th power, y to the 7th power. Which brings me to this question here. What would happen if the bases are different? Could you add the powers? No. So the answer is no. Reason being, the bases are different. So if the bases are different, we cannot just add the powers. Alright, so we cannot add the powers. So here, if you note, we have 2 to the 3rd power, which means that the base here is 2 and the power here is 3, times 3 to the 2nd power, which means that the base here is 3 and the power is 2. So because the base are different, in this case we cannot add the powers. Okay, so we only add the powers when the bases are the same, as you can see here. Okay, law number 2, division of indices. When dividing indices with the same base, we keep the base and subtract the powers. Alright, example number 1. X raised to the power of m divided by x raised to the power of n is going to equal to x raised to the power of m minus n. Example 2. A to the 3rd power divided by a squared is going to equal to a to the 3rd power minus the 2nd power. So clearly the base are the same, so we simply subtract the powers. Example 3. K to the 9th power p to the 3rd power divided by k to the 2nd power p to the 2nd power is going to equal to k to the 9 minus 2 p to the 3 minus 2, which gives us a final answer of k to the 7th power and p to the 1st power. Alright, example 4. 9a to the 5th power divided by 3a to the 3rd power, then this is going to equal to 9 divided by 3, and put the a here, and then it's going to be 5 minus 3. So it's going to be 5 minus 3, which gives us a final answer of 9 divided by 3. It's going to give us 3, and a, and 5 minus 3, that's going to give us 2. So our final answer is 3a squared. Example number 5. 27x to the 4th power y to the 6th power divided by 9x to the 2nd power y to the 4th power. So what we're going to do is to divide the coefficient of each term. So if we divide 27 by 9, that is going to give us 3. Then it's going to be x to the 4th power minus the second power. Then we keep our base of y. It's going to be y to the 6th power minus the 4th power, which gives us a final answer of 3x, and 4 minus 2, that's going to leave us with 2, and keep our y, and 6 minus 4, that's going to leave us with 2. So our final answer is 3x squared y squared. Alright, to number example 6, we have 24k to the 5th p to the 4th divided by 12k to the 6th and p. Remember that this p here means p to the 1st. Alright, so we're going to divide the coefficient of each term. So it's going to be 24 divided by 12. Put that in a bracket. Then we are now focusing on our k term. So k is the base here, so we're going to keep our k. And we're simply going to subtract the power, so it's going to be 5 minus 6. Then now we are going to focus on our p term, where p is the base in this case, so we're going to put our p. And we're simply going to subtract the powers, which is 4 minus 1. And we simplify this to get a final answer of 24 divided by 12, that's going to leave us with 2. Then we put back our key. And 5 minus 6, that's leave us with negative 1. Put back our p. Combine the index of 4 minus 1, that leaves us with 3. So our final answer is 2k to the negative 1, p to the 3rd power. Alright, to our final example, here we have x to the 5th power, y to the 2nd power, z to the 4th power divided by y to the 3rd power, z to the 3rd power. Now, what we're going to do is to write back our x term. So it's going to be x to the 5th. Since there is no x over here, we can't do anything to it. So now we are going to move to our y term. So we're going to keep our y as the base, and the index we are going to subtract. So it's going to be 2 minus 3 here. So it's going to be 2 minus 3. Then we're going to keep our base of z, and then it's going to be 4 minus 3. Then we simplify, and when we simplify this, we're going to get x to the 5th power, y, 2 minus 3, that leaves us with negative 1. So it's y to the negative 1, and then it's going to be z, and then 4 minus 3, that leaves us with 1, which is just the same thing as us z. Alright, so our final answer is x to the 5th, y to the negative 1, and z to the 1. Alright, so you can try this question for yourself, which is 16x to the 10 divided by 2x to the 4th, which is going to give you a final answer of 8, because 16 divided by 2, that's 8, and then it's going to be x as the base, and you subtract the power, so it's going to be 10 minus 4, that leaves you with 6. Alright, number 3, power to a power law. To raise a power to a power, keep the base and multiply the indices. So in other words, what you're going to do is to distribute the power outside of the bracket to each power. inside of the bracket. So example number 1, we have a to the m in bracket raised to the power of n. So we are going to take this n to multiply the m, so it gives us a to the m times n, which gives us a final answer of a to the mn without the multiplication sign. Alright, so example 2, x to the 5th raised to the second power, power to power, we multiply the power, so that gives us x to the 5 times 2, which gives us x to the 10. Example 3, we have x squared y to the 3rd power, all of that being raised to the 2nd power. So power to power rule, we take the power outside to multiply each power inside of the bracket. So it's going to be x squared times 2, and then y to the 3rd power times 2, which gives us a final answer of x to the 4th, y to the 6th. So let's look at example 4. Here we have 5x squared all raised to the 3rd power. Remember that 5 by its here is the same thing as 5 raised to the power of 1. So applying the power to power rule, then it's going to be 5, which to keep the base, raised to the power of 1 times 3. Then we're going to keep our x, and then it's going to be 2 times 3, which gives us a final answer of 5 to the 3rd power and x to the 6th power. Now note that 5 to the 3rd power can be simplified because this 3 is telling you how much time you must multiply the base by itself. So 5 to the 3rd power is the same thing as saying 5 times 5 times 5, which is going to give you 125. So this can simplify to be 125 x to the 6th power. Alright. Now let's look at example number 5. Same idea. 3 here is the same thing as 3 raised to the power of 1. So this is going to equal to 3, which is the base, raised to the 1st power, times the power outside of the bracket, which is 4 in this case. Put back our x as the base. So it's going to be x squared, multiply by the power outside, which is 4 in this case. And we simplify this, we're going to get 3 to the 4th times x to the 2 times 4, that's going to give us 8. But note that 3 to the 4th can be simplified, right? That's just 3 times 3 times 3 times 3. And 3 times 3, that's going to give us 9. And 9 times 3, that's going to give us 27. And 27 times 3, that's going to give us 81. So this can be simplified to be 81x 8 power. Now to example number 6. Here we have 2x to the negative 2, y to the positive 3. All of that in bracket raised to the 4th power. So remember, 2 by itself is the same thing as 2 raised to the power of 1. So we're going to take the power outside of the bracket to multiply the power inside of the bracket. So this is going to give us an answer of 2. So 1 times 4, that's us 4. So it's going to be 2 raised to the 4th power. Back our x. Then multiply the powers. So negative 2 times 4, that's going to give us negative 8. So x is raised to negative 8. Put back our y as the base. Multiply the powers. So 3 times 4, that's going to be 12. And you can always simplify this some more. So 2 to the 4th means that you're going to multiply 2 by itself 4 times. It's going to be 2 times 2, which is 4. 4 times 2, which is 8. And 8 times 2, which is 16. So that's going to give us 16 x to the negative 8th power and y to the 12th power. All right. To our final example now, what we have here is 2 bracket p squared q, all of that raised to the 3rd power. So here, note that the 2 is not inside of the bracket. All right. So what we're going to do is to keep our 2 as is, open our bracket, and then it's going to be p raised to the 2nd power, multiply by the power outside of the bracket, which is 3 in this case. Then q, remember that q by itself is the same thing as q to the 1st power. So it's going to be q to the 1st power multiplied by the power outside of the bracket, which is 3. And then we close our bracket, which is going to simplify to give us 2, right? P, and 2 times 3, that's 6. So p to the 6 and q to the 3rd power. Law number 4, negative power. A quantity with a negative power is the inverse or reciprocal of a quantity with a positive power of the same magnitude. Alright, so what this is saying, if you have an index that is being written in negative form, for example, number 1 here, m is raised to the negative n, then this is equal to the reciprocal of this, which is 1 over m to the positive n. Alright, let's look at example 2. Here we have 3 to the negative 2. This is going to equal to 1 over 3 to the positive 2. And when we simplify, we would get 1 over 9. Alright? Example 3, we have a to the 3rd power divided by a to the 5th power. In order to simplify this, we first have to apply the division law. It says once the base are the same, we simply subtract the power. So here we have a to the 3rd power minus the 5th power, which gives us a to the negative 2. Now, because we want to write this in positive form, then this is the same thing as saying 1 over a squared. Alright? Let's look at some more examples. So example 4, we have 3 raised to the negative 3, and we want to write this in positive form, then this is going to equal to 1 over 3 to the 3rd power. Alright? Which is the same thing as 1 over 27. Okay? Alright, example 5, we have 4 to the negative 2, then this is the same thing as 1 over 4 squared, which is equal to 1 over 4 times 4, which gives us a final answer of 1 over 60. Example 6, we have 2 to the negative 3, then in positive form, this is equal to 1 over 2 to the positive 3, which can be simplified as 1 over. So remember that the power here tells you how many times to multiply 2. So it's 2 times 2 times 2, which gives us 8. If you're wondering how I get 1 over 8. Now let's look at the reverse. Now we're given the positive form and we want to write it in negative form. So here we have 1/5. Then this is equal to, if we bring this 5 from below the denominator here, then it's going to equal to 5 to the negative 1. Alright, let's look at example 8. We have 1 divided by 3 squared, which is going to equal to 3 to the negative 2. Here we have 1 over x to the third power. Then this is the same thing as x to the negative 3 power. Here, for number 10, we have 3 divided by y to the fourth power, and we want to write this in negative form. Then this is going to equal to 3y raised to the negative 4 power. Okay? Try these. Simplify these and leave your answer in the positive index form. So the first one we have is a squared divided by a to the 5th. First thing that we're going to do is to apply the division law. It says that if the base are the same, we simply subtract the power. So we're going to keep the base of a and subtract the power. So 2 minus 5, that leaves us with negative 3. So it's going to be a raised to the negative 3. But we must also write our answer in positive index form. So this is the same thing as 1 over a raised to the third power. Alright? Now part B, we have p to the 5th power, all of that in bracket, have been raised to the negative 2 power. So first, we have to apply the power to power rule here, which is to take the power outside of the bracket to multiply the power inside. The first thing, we're going to keep our base, which is p in this case. And negative 2 times 5, that's going to give us negative 10. Now we must write this answer in positive index form. So this is the same thing as 1 over p raised to the 10th power. For the last one, here we have a to the 24 divided by a to the 25th. So we're going to apply the division law first, which is to keep the base and subtract the powers. So the base is a. If we subtract the powers, 24 minus 25, that leaves us with negative 1. And then we need to write our answer in positive index form. So this is going to equal to 1 over a. And that's it. Okay? Thank you for watching. Please remember to like, comment, and subscribe.